All right, welcome to Exponents, week 4. Let's get started. All right, so we are going to complete each table with the writing each as an expression based off of a base and an exponent. So just so you know, the expression that we write that has like this is called a power. That is called a base. And that is called an exponent. Okay, so if we're completing the table here, they've given us n values, so 0, 2, 4, 6, 8, 10, and 12 in this case, and they want us to square it. So here we're saying 0 to the second power, 2 to the second power, 4 to the second power. You see, because all we want to do is we want to replace n, okay, which is our base, with these numbers here. Okay, they've given us our exponent. Our exponent is not changing. Our exponent is 2. So our 2 is staying constant. Our base is what is changing. Now, if they wanted us to evaluate, then we would say, 0 times 0, 2 times 2, 4 times 4 times 4, 6 times 6, 8 times 8, 10 times 10, and 12 times 12. Because really what you're saying is you have the base that many times, all right? The base is what you have. The exponent is how many times. Okay, so 0 times 0 is 0. 2 times 2 is 4. 4 times 4 is 16. 6 times 6 is 36. 8 times 8 is 64. 10 times 10 is 100. 12 times 12 is 144. Again, these are all numbers that you see on a multiplication chart that go down along the diagonal line. These are all perfect square numbers, which we will talk about more at a later date. So in number 2, we're going to do the same thing. We have this base. We have this exponent of now 3. So when we're changing our base, we want 1 to the third, 3 to the third, 5 to the third, 7 to the third, 9 to the third. And if we were evaluating it, which they didn't ask for, but it's good to just know what they're asking us for, the base is what we have. The exponent is how many times. So really here we would have 1 times 1 times 1, or 3 times 3 times 3, 5 times 5 times 5, 7 times 7 times 7, 9 times 9 times 9, okay? So 1 times 1 times 1 is 1. 3 times 3 times 3 is, 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. 25 times 5 is 125, and so on, okay? Express each number as in terms as a power. That doesn't make sense, but express each number as a power of 10 in terms, I don't know what that was supposed to say. I will figure that out and fix it on the independent one. But in terms of 10, what power would you have to raise 10 to get 100? Well, 10 times 10, how many times would give you 100? Well, it would only be 2 here, right? Because 10 times 10 would give you 100. Well, that's 10 raised to the second power. How many 10s would we need to multiply by itself to get 10,000? we would need 4. And I'll give you a hint. It is as simple as it seems in that the number of zeros here is the number of zeros here. So 1, 2 here, 1, 2, 3, 4 there. So 1, 2, 3, 4, 5, 6, we need a 6 as our exponent here. All right, write each number in terms of powers here. 2 times 2 times 3 times 3. Well, we have the bases. So remember, the bases is what we have. The exponent is how many we have. So how many 2's do we have? How many 3's do we have? We have 2 2's and we have 2 3's. So we have 2 to the second, 3 to the second. All right. So for number 7, 5 times 4 times 4 times 4. How many 5's do we have? How many 4's do we have? We have 5 to the first, 4 to the third. This can also be written as 5 times 4 to the third. If there's no exponent on something, no exponent is understood as an exponent of 1. Now, if we want to write each number in standard form is a fancy way of saying the numbers as we know it. So if we want 6 to the second times 5 to the second, what we're really saying is the opposite of what we just did. We're saying 6 times 6 times 5 times 5. Well, 6 times 6 is 36. 5 times 5 is 25. Not necessarily a fun multiplication problem for us to do, but one that we can do nonetheless because we've done it a couple weeks ago. So we do 36 times 25. 6 times 5 is 30. We carry the 3. 5 times 3 is 15, plus 3 is 18. So we get 180 for that one. We're going to bring down the 0 as a placeholder, and now we're going to multiply with the 2. 2 times 6 is 12. We're going to carry the 1. 2 times 3 is 6, plus 1 is 7. 0, 10, carry the 1, 7, 8, 9. And we get 900. So 900 is a number in standard form. So remember, standard form is just a number as we know it. Nothing fancy. Not a number written out as in words, not a number in expanded form, not just a regular old number. Okay? Now, if we want 10 to the third times 9 to the second, we want 10 times 10 times 10 times 9 times 9. So 10 times 10 times 10 is going to be 1 with 3 zeros attached, or 1,000, and 9 times 9 is 81. Well, remember the trick we learned. That's 81 times 1, and then we can add the 3 zeros afterwards. So 81 times 1 is just 81, and then we can attach those 3 zeros to the end and get 81,000. And that's it. Make sure you reach out with questions, try that independent work, check your answers on the keys, and I will see you at the live.